Hello. So I am going to discuss this question which says which of which one of the following graphs represent the variation of maximum kinetic energy of emitted electrons with frequency nu in the photoelectric effect correctly. Okay. So you must have read the Kmax formula. It is h nu minus phi. H is the Planck constant, nu is the frequency of incident photon, phi is the work function, H is the Planck constant, and nu is the frequency. Okay, so here the symbol in the question is EK. So EK is equal to h nu minus phi. If you compare it with the standard linear equation, it is y is equal to mx minus c. So its y-intercept is negative and its slope is positive. So if we go one by one option, so this is option A says it is a straight line passing through origin, y is equal to mx. This is not the correct answer. Here intercept is positive in the option C. Intercept is positive, slope is positive, but intercept is positive, which is wrong. Here slope is negative, so this is also the wrong option. So the correct option is D, that is having slope positive. And if you extend this graph backward, you will get as negative slope, negative intercept. So the correct answer is D. Hope this explains your question. Thank you. This is the next question. The stopping potential V0 versus frequency plot of a substance is shown in the figure. The threshold wavelength is, okay. So you have been given stopping potential and frequency graph. So let's first find the equation. So EVS is equal to HF minus phi. Okay, EVS is HF minus phi. This is the equation of the photoelectric effect. We have to find the threshold wavelength, and we have been given, you just see the stopping potential. If you put a stopping potential is 0, so HF minus phi, so here it will be threshold. So minimum frequency of a photon which can eject a photoelectron is called threshold frequency, and in that case the stopping potential should be 0, and that value we have been given is 5. So 5 into 10 to the power 14 is your threshold frequency, and we know that lambda times frequency is the speed of light c. So if we want to calculate lambda threshold, it will be c by f or nu. So it will be 3 into 10 to the power 8 and divided by 5 into 10 to the power 14. So if you cut it, it will be 10 power minus 6, plus 6, and if you can take it up, it will be 3 by 5 multiplied by 1000, you will get nanometer. So that will be 200. So your answer will be 600 nanometer or 6000 angstrom. 600 nanometer or 6000 angstrom. So your correct answer is B. So hope this explains your question. Okay. Now the third question. Good morning. Here is the question. The photoelectric effect. In photoelectric effect, work function of a metal is 3.5. So you have been given work function 3.5 electron volt. And the stopping potential, the electrons can be stopped by applying a potential of minus 1.2 volt. So stopping potential is already given negative. So if we take negative out, so it will be 1.2 volt. Okay. Negative means it is the voltage of anode with respect to cathode. So we take the magnitude value and it is 1.2. Then we have the formula EVS is equal to HF minus phi, or EVS is equal to energy of photon minus phi. So what could be the energy of photon? E times stopping potential and plus phi. So that will be 1.2 electron volt and plus 3.5 electron volt. So energy of the photon will be 4.7 electron volt. 4.7 electron volt. So the correct option is A. And obviously this is the wrong. Higher frequency photon, the photoelectric current will increase. This is also wrong, because photoelectric current is proportional to intensity of the light. If you increase the intensity, you must have read this concept that the intensity and photo current, saturation current, whatever, it is proportional to intensity. So if you increase frequency, the current will not increase. So this is also wrong, which when the energy of photon is 3.5, the photoelectric current will be maximum. So the photoelectric current depends upon intensity. It has nothing to do with the energy of the photon. So this also is wrong. So the correct answer is A. So hope this explained your answer. Thank you. Have a nice day.